and welcome to the lab. In this video, we're going to explore the reactivities of some of our alkali earth metals with water. So I have 3 test tubes and I have 3 metals. I have lithium, sodium, and potassium. Now, all 3 of these metals have 1 valence electron, and they're pretty reactive. They very easily lose that 1 valence electron and go into solution. In fact, they're so reactive that we have to store them in mineral oil because they would react with the water vapor in the air. So if I drop pieces of these into water, what's going to happen? So I'm going to take a test tube. I'm going to put in some deionized water. Okay. Now, to my deionized water, I'm also going to add some phenolphthalein. Phenolphthalein is an acid-base indicator. In an acidic solution or a neutral solution, it is completely colorless. And in a basic solution, it is bright pink. All right, now I went to go add my phenolphthalein, and my phenolphthalein has crystallized out of my dropper. So if you give me just a moment here, I need to grab a disposable plastic dropper that I can use until I can clean out my dropper. All right, so I'm gonna go ahead and drop some phenolphthalein. Now it doesn't take much phenolphthalein, so I'm just gonna add in like 3 drops, okay? So you can see that I still have a clear and colorless solution. Okay, so the first metal that we're going to test the reactivity on is lithium. So I'm going to go ahead and take out a piece of lithium from my little vial here. Now, again, this is stored in mineral oil. So what I have to do is I have to take my metal and I have to put it on a piece of paper towel or filter paper or something that I can blot off the mineral oil. So you can see that I've got an oil spot on here. So I'm gonna go ahead and blot it off. Okay, pick it back up with my tweezers. All right, and now we're simply going to take that, get it off the tweezers, and react it with the water. Oh, what happened? It immediately turned bright pink. So that means that as this reacted, well, you can probably hear it fizzing. There it goes. All right, so did a reaction happen there? Absolutely. So lithium is so active that it can displace hydrogen from water. And so that fizzing and that bubbling there, that was hydrogen gas bubbling out of our water. And as the lithium went into solution, it made the solution basic, because as it displaced hydrogen ions, we ended up with some hydroxide ions, all right? And hydroxide is basic. All right, so there's our first metal. All right, let's do the same thing, all right? This time with some sodium. All right, so we'll add our deionized water to our test tube. Okay, again, there's our deionized water. Okay, let's add some phenolphthalein. Okay, just takes a little bit. All right, as you can see, I got a little cloudy, probably from the stuff the phenolphthalein is dissolved in. I accidentally squirted a little more than I wanted to in there. We should still be okay. Okay, so now I'm gonna pull out a piece of my sodium, put it down like we did before. Let's try to get as much of that. You can see there, sodium's a little different looking than that lithium. It's a more of a white color instead of that dark black. All right, let's try to get off as much of that mineral oil as we can. Okay. Pick it back up with the tweezers. Okay, and then we'll go ahead and drop it into our test. Ooh, there we go. All right, that one was a little bit more violent there than that lithium was. Okay, oh, still going a little bit. So same thing. Sodium is so active, it can displace hydrogen from water. And so we get hydrogen gas coming off and we get hydroxide ions being formed, and voila, we see that basic solution. Okay, now let's try it with one more. Let's see what happens with our potassium. Okay, add some water in. Okay, there we go, there's our water. All right, now we'll get that phenolphthalein. There we go, just 3 drops. Okay, once again, still nice and colorless there. All right, so now we'll get our potassium. Okay, so we're gonna pull it out of our mineral oil, drop it onto our paper here. Okay. And there you can see the potassium metal on the paper. All right, we're gonna let it dry. These are actually fairly malleable too. I can squish that piece. I kind of flattened it there. Okay. All right, let's pick it back up off that filter paper and drop it in. There we go. We got a nice pop out of that one. Okay. So, and that one reacted pretty quickly. The potassium is a little bit more violent reaction than the other two. When we check the activities of all 3 of these against each other, we actually find out the potassium is more active than the sodium, and the sodium is more active than the lithium. Hence the reason why the potassium popped and gave us a more violent reaction than the other 2 did. All right, and once again, we've displaced that hydrogen from our water. We're forming our hydrogen gas there. It's lingering longer because it formed a little bit quicker, and so it's not bubbling off the same way the others did. And that hydroxide ion is there, and our phenolphthalein turned bright pink. Okay, so that is the reactivities of our group 1A metals with water.